Hello! In this video, I'm going to teach you how we can model complex decision-making processes in our heads. So how do we do that? Well, we're using something known as nested conditionals. Well, what on earth is that? Well, we've already learned about conditionals like, if, right? The if formula in Excel. So a nested conditional is basically putting an if inside an if. And in fact, you can nest as many ifs if you want. See what I just did there? Okay, pun intended, yeah? Now, what's the one thing that's always on our minds? Isn't it always about food, yeah? You're always hungry, thinking what to eat, where to eat, what to eat for the next meal, yeah? Even when we're eating, yeah? But suppose I present you this very, very mysterious object. Would you dare to eat it? Well, you might say no, or you might say, maybe I'll just eat this as the last resort. But how did you arrive at this decision? So let's try to model this decision-making process, okay? Let's say there are 4 possible outcomes. Number 1, must eat. Number 2, eat if you must. Number 3, don't eat. And number 4, not edible. So let's begin. For starters, let's check if the object can be soloed. We'll use a tree diagram to help us map out the conditionals, alright? So, can I solo it? Now, if you remember, a few lecture videos ago, I taught you about necessary and sufficient. Yeah? So we can say that not being able to solo something is a necessary condition for it to be not edible. Now, is this a sufficient condition? We say something is sufficient when we have said all that needs to be said about it. Well, since we cannot solo it, it is, after all, not edible at all, right? So we have said all that needs to be said, and therefore the condition not being able to solo is both necessary and sufficient. And so we can just end this branch of the tree diagram over here. There's no need to probe any further. But what if the thing can be soloed? Can we then say that it is edible, that we can just eat it? Well, if you think about it, there are many things that you can eat, right? But some things you can only eat once because you eat it and then you die, right? So being able to solo is a necessary condition, but it is not sufficient. We still need more conditions to decide. So let's ask, if I solo this, will I die? If yes, then we can safely conclude that this is a don't eat, yeah? Is this all that we have to say? Yes, right. In which case, being able to solo and dying from it are both necessary and sufficient conditions to the outcome don't eat. Now, if you notice, we still have 2 more outcomes that we want to classify. Must eat and eat if you must. So what distinguishes an object that is must eat from an object that is eat if you must? I know. If it's delicious, then it's a must eat. Like ice cream, for example. Ice cream is so delicious. If you tell me it is ice cream, I'm so gonna eat it, right? But think about celery. Right. Do I really want to eat it? No, not at all. But if it's the last thing on earth for me to survive, then yeah, maybe I'll eat it, yeah? So let's use deliciousness as a condition, alright? In which case, deliciousness is that condition that distinguishes between the 2 outcomes, right? So if it's delicious, it's a must eat. And if it's not, it's an eat if you must. Well, now that we have this tree diagram, what's next? I want to show you this thing called pseudocode. What is this pseudocode thing, right? Pseudocode is a fake coding language. It's supposed to help us think more algorithmically, yeah? It's a useful stepping stone to help us understand the basic foundational concepts of algorithm design. So we'll start with the top level conditional, which is the first question that we'll ask. If can solo, then, now we'll add a placeholder here because we're going to add more stuff here later. Else, again another placeholder, and then and if. Now, you must be thinking, what is this and if? And if is like the close bracket of your Excel if formula. So after you're done writing everything, you must close the bracket. So similarly, after you're done with your if conditional, you need to have a and if to end it. It's just our way of saying, this is the end of the if conditional. That's all. So now, let's follow this branch on our tree diagram, shall we? The next question we need to ask is, will I die if I solo it? Because this is the follow-up question for the question, can it be soloed? We'll park that question in here. We're going to nest it inside. So our pseudocode will now look like this. If can solo, then, so we'll add this. If will die, then, and of course we have our placeholder, more to be added here, and so on, right? Now, notice how I'm writing this. The line, if will die, then, is push, or what we call indented to the right. Now, what's the whole point of doing this? This is to say that anything pushed to the right belongs to the nearest line above it, that is on the left. Okay? In this case, if will die, then is on the right, and so therefore it belongs to if can solo then. And if you look further, you'll see that if will die then and the else and the and if, they're all indented to the right, so they all belong to the if can solo then. Now, let's follow the yes branch of our tree diagram. It ends with a don't eat. So we can put that inside our pseudocode and it'll look like this. If can swallow then, if will die then, don't eat, else, and so on, right? Now, notice that don't eat is pushed to the right of if will die then. Yeah? This means that don't eat belongs to if will die then, which belongs to if can swallow then. Now, let's trace the other branch. What happens if we don't die? Then we can now ask the question, is it delicious? Oh, yum. Now, because this is a no in our tree diagram, we'll park this in the else portion of the conditional. So it'll look like this. Now, let's trace our tree diagram. If it's delicious, we conclude with must eat, right? Otherwise, else, we'll conclude with eat if you must. And we'll park it into our conditional and it'll now look like this. If can swallow then, if will die then, don't eat. Else, if delicious then, must eat. Else, eat if you must. And if, and so on, right? Now, if you notice, we have one more placeholder in our pseudocode, right? Something else has to be added. That's the last branch in our tree diagram that we haven't traced yet. Yeah? So let's trace that last branch, okay? So what if it cannot be swallowed? It's therefore inedible, yeah? So we'll put that in the top level else. And now our pseudocode will look like this. Okay, so now the question is, how do we do this in Excel? So let me show you. Okay, so let's open our lecture activity spreadsheet. Now, as you can see, we have the following columns. Column A contains the list of items, right? Column B will tell you whether you can swallow it. Column C will tell you whether you will die from it. Column D will tell you whether the item is delicious. So, how do we nest it? So very simply, it's the same as how we would do the normal if formula. So equals to if. Okay, so let's do the top level, which is the first question that we'll ask, right? If can swallow, right? So if B2, okay, equals to yes, right? Now, we're not going to do anything yet. We're only going to put in placeholders. So let's just put a Y so that we know that this is what to do if it's a yes, okay? And we put a N, or what to do if it's a no, yeah? And then we close bracket. Now, as you can see, this is working fine. Now, let's put in our second conditional, which is this one, if will die then. Now, if you remember, because this is indented, push to the right, this comes under if can swallow then, right? So, what I'm going to do is, I'm going to put this to replace the placeholder that I have over here. So, let's just type if, open and close bracket. Let's go back in, and we'll type if will die. So, that will be if C2 equals to yes. Alright? Again, we're going to put our placeholder. We put another Y and then we put another N. Okay, just like this. Alright, now we press enter. Okay, it is working. Yeah, so far so good. So now, as you can see, I have B2 and C2. If can swallow, if will die. Now, what do we have next? We have if delicious then. So where do we put the if delicious? If you notice, the if delicious comes under the else. This statement belongs to the else, which belongs to the if can swallow then. So that means that this will fall under the no component. Okay, so now what do we do next? Now that we know that our formula is working, well, we know that if the answer is yes, we will put the word don't eat. So we'll go back and edit our formula. We'll delete the Y and we'll type don't eat. Enter. Okay, so we have that. Now, else will be the thing that will go into this portion over here. So what do we do under the else? If you notice, we have another if conditional that is nested, right? So we're going to delete this placeholder and we're going to type if bracket bracket, okay? And then we go back inside the bracket over here. And now we're going to type the delicious, right? So delicious is cell D2, yeah? So if cell D2 equals to yes, okay? Now again, we will put a placeholder, a Y and a N, okay? And then we press enter. Now let's go to the next line, which is, so if it's delicious, then the answer is must eat, else eat if you must. So let's just replace the Y with a must eat, and we will replace the N with a eat if you must, okay? And now we finally have a different outcome already, yeah? Now, remember what we did next? The last thing was the else inedible. Now, where does the inedible fall under? Which if statement does it belong to? If you notice, this is on the right of this else. So that means this belongs to this else, which is the same as our top level if. In fact, if we look carefully, this is the last placeholder that we have. Everything else has been filled in. So you can just remove the N and put the word inedible like so. And just like that, we're done nesting our conditionals. And so we just expand and voila, we're done. Now you must be wondering, why am I teaching you to write the if formula in such a convoluted way where you type a bit, you press enter, you type a bit, you press enter? Because it is so easy for us to make mistakes, yeah? I know it's very convenient to go from left to right, but sometimes when we just type from left to right all the way, we can miss out certain punctuation, alright? So let me give you an example. One typical example is when we forget to put the close bracket. Something like this. And then you get this error which says that you've entered too many arguments for this function. Now, this is not because we have too many arguments. You can nest as many ifs as you want in Microsoft Excel, okay? Why is this the problem? Because if you notice just now I deleted a bracket, right? So what happens is, because the if formula only allows 3 inputs, but because I deleted a bracket, it looks like I have 4 inputs. So if you see over here, I have this bracket over here, right? So input 1 is here, input 2 is here, and then input 3 is this whole thing. And then suddenly I have an input 4, which is this thing over here. And so that is why Excel got so confused. It's like, oi, how come you got 4 inputs? So that's because we have a missing bracket. So there, how do we fix this? You just find the missing bracket and you put the close bracket and press enter. Of course, this could have been easily avoided if you did the nesting solution that I showed just now. And so if you did the nesting method that I showed you just now, do bit by bit, put the placeholder here and there, you will have very little problems, maybe almost no problems when you're nesting your conditionals. And just like that, we have come up with the answer on what to do with all these items. Okay, so that is all about how we can model our decision-making process, right, using nested conditionals. So, all the best. I'll see you around. Bye!